Welcome to Knowledge Hub. Today, we're diving into one of the most awe-inspiring processes in the universe, the birth and death of stars. The birth of a star, a cosmic nursery. Stars are born in vast, cold clouds of gas and dust known as nebulae. These regions, sometimes called stellar nurseries, are where the journey of a star begins. Within these nebulae, gravity pulls the gas and dust particles together, causing them to clump and compress. As these clumps grow denser, the temperature at their core rises. When the core temperature becomes high enough, nuclear fusion ignites, marking the birth of a new star. This process of fusion, where hydrogen atoms fuse to form helium, releases an immense amount of energy, causing the star to shine. The life of a star. Main sequence stability. Once a star is born, it enters the main sequence phase, the longest stage of its life cycle. During this period, the star maintains a delicate balance between the inward pull of gravity and the outward pressure from nuclear fusion at its core. For most stars, including our Sun, this phase lasts for billions of years. The star steadily burns hydrogen into helium, producing light and heat that radiate into space. The duration of the main sequence phase depends largely on the star's mass. Massive stars burn through their fuel more quickly and have shorter lifespans, while smaller stars can remain stable for tens of billions of years. The evolution of a star from giants to supergiants. As a star exhausts its hydrogen fuel, its core contracts while its outer layers expand, leading to the next stage in the life cycle. For medium-sized stars like the Sun, this results in the formation of a red giant. In this phase, the star's outer layers are pushed outward, causing it to swell dramatically. The core, now primarily composed of helium, begins to fuse into heavier elements like carbon and oxygen. For much more massive stars, this expansion can lead to the formation of a red supergiant, an even larger and more luminous version of a red giant. The death of a star. The final act. The death of a star depends on its mass. For low to medium mass stars, once the core's fuel is depleted, the star sheds its outer layers, creating a glowing shell of gas called a planetary nebula. The remaining core becomes a white dwarf, a small, dense remnant that will gradually cool and fade over billions of years. Massive stars, on the other hand, end their lives in dramatic fashion. After burning through their nuclear fuel, they undergo a catastrophic collapse that triggers a supernova explosion. This explosion disperses the star's outer layers into space, leaving behind a neutron star, or, in the case of the most massive stars, a black hole. These remnants, though small, are incredibly dense and have a profound impact on their surroundings, influencing the formation of new stars and the evolution of galaxies. The cycle continues. The materials ejected from dying stars contribute to the cosmic recycling process, enriching the interstellar medium with heavier elements. These elements, once part of a dying star, may eventually form new stars, planets, and even life. Thus, the birth and death of stars are part of a continuous cycle that shapes the cosmos. Conclusion: the stellar life cycle is a testament to the dynamic and ever-changing nature of the universe. From the quiet birth in a distant nebula to the explosive death in a supernova, stars play a crucial role in the evolution of galaxies and the creation of the elements that make up everything we know. As we continue to study the stars, we uncover more about the origins of the universe and our place within it. Thank you for joining us on this cosmic journey here at Knowledge Hub.